Welcome again to Let's Talk Forensic with Pastor Dan. We're going to continue our examination of trace evidence by looking at glass analysis. And glass analysis is the means of connecting glass fragments from crime to a specific suspect. So making sure that the glass that we find matches up with a suspect, it's a form of trace analysis. All right, so main ways that we can match glass evidence. First is called density, and we'll talk about that in a second. Second is something called refractive index, and the third is pattern matching. Now, for density is defined as the mass of a substance per unit volume. We have an equation for that. Capital D, small d means distance, is equal to small m, which means mass, capital M means molarity, divided by capital V, small v means velocity. So D is equal to M over V. All right, so what we're going to do here is we'll take a problem. Find the density if 3.98900 grams of glass has a volume of 2.00 milliliters. So we find the mass, we find the volume. We're going to take our equation, D equals M over V, plug our values in. D is unknown, mass is 3.900 grams, volume is 2.00 milliliters. Plug those in, divide those through. When we do, we get 1.95 grams per milliliter. Grams per milliliter is the units, or are the units for density. All right, now, there is another way. I want you to look at this one here, and what you're going to do is you'll find the density of 20 divided by 16, and when you do that, try it on your own first. Get a calculator out here quick. Whoop, come on. Our answer is going to be 1.25 grams per milliliter. All righty, good. Now, there is the way that we find the volume, because we can't exactly measure a piece of shard glass. So we do something called water displacement. What we do in water displacement is we take, I have the answers all there for you. All right, good. We take a volume of water and we throw the item into it. And the water will raise up by knowing the distinction difference from what it was to what it is afterwards. That's how we have it. The definition method to determine the volume of a regularly shaped object by seeing the change in volume it generates. Now, there is a problem with doing density for glass. First of all, they're extremely light. And second, they're somewhat close. It's so light that some glasses actually float. It has a density less than 1. So what do? The solution is something called suspension analysis. I've got an image of water inside of there. And what you're going to do is you're going to take a known density of liquid, and that object will float in there. Once we get that positioned and we know the density of the liquid it's floating in, that density is the density of the glass. That's how suspension analysis works. Now, the other thing we talked about is something called refractive index. Refractive index is measure and tendency of light to bend as it moves through different substances. So we're going to take the temperature and make sure that's recorded at a specific temperature, and then the instrumentation. Here is the device, so you can take that piece of glass, put it in this little opening here, light goes through it. The amount of light that goes through before, amount of light that goes afterwards, that change in refraction, bending of light like they did in the breathalyzer, that is the refractive index, and we can match that glass to the glass at a crime or whatever in that way. All right, now pattern matching. We're going to do a lab with this, and you got to be very careful, but this is really, really fun. What you're going to do here is you're going to take a broken shard of glass and match it to a piece of glass. Find out a crime scene. Let's say someone breaks into a window and the glass is shard. Maybe some of that glass got caught in the person's pants or sleeve or something like that. We find it. So what we're going to do is we'll take a piece of glass that we find, take the shard, and match it up. So you can literally do that. Try to see if you can match those glass pieces up. All right, that's it. Hopefully not too bad. Take care. God bless. Bye.